So in today's lecture, we are going to learn how to find the solution of non-homogeneous linear differential equation. If you remember, as we agreed that starting from Sunday lecture, we are going to learn how to solve higher order differential equations. So second order, third order, and so on. And in the previous lecture, we studied how to solve homogeneous linear differential equation with constant coefficients. Can any one of you remember what is the meaning of homogeneous differential equation, homogeneous linear differential equation? Do you remember?
When gx is 0?
Yes, the right-hand side, my function gx is equal 0. So this equation, x prime, or just a minute, y double prime plus y prime minus y equals 0. This equation is homogeneous because the right-hand side is 0. But if the right-hand side, it isn't 0, maybe it is x, so this equation is non-homogeneous. Okay, so in today's lecture, we are going to learn or to discuss how to find the solution of this equation. The right-hand side isn't 0. And by the way, if the right-hand side is 0, as we did in the previous lecture, so here my right-hand is 0. So do you remember how to solve this equation? If the right-hand side is 0 and the coefficients are constant numbers. So how to solve this one?
Using the auxiliary
Using the auxiliary equation. So m squared plus m minus 1 equals 0. You will solve this equation. And here you have three different cases when the m1 not equal m2. And in this case, I have two solutions, e to the m1x and e to the m2x. And second case, if you remember, when m1 equal m2. And in this case, I have the first solution as usual, e to the m1x. But the second one, I must multiply it by x. Okay. The third case, let me write it here. When I have my m1 and 2 are complex numbers, alpha plus or minus beta I. In this case, the first solution, it will be e to the alpha x cosine beta x. You have to write those in your cheat sheet. And e to the alpha, the second solution, sine beta x. Okay? So all those we studied, and in today's lecture, we are going to study how to solve non-homogeneous differential equation. But notice, your coefficients must be constants. Here are the objectives of our lecture. And let us now, actually in this slide, as I add here the revisions, like if your m is repeated here, so you need to multiply by x squared and x cubed. But if your m's are different, so we'll use this formula. Okay, this we studied in the previous lecture. And this one also, this problem depends on the previous lecture, and I'm asking you now to do it and send it to me on WhatsApp as a private message. Okay? Here the question, I give you the solution and you need to find the differential equation. And by the way, we solved two problems similar to this one in the previous lecture. One during our class, and the second one in the solving the worksheet. So please here do this one and send it to me on WhatsApp as a private message. You need to determine the differential equation which accepts this function as a solution. Okay? Now, before we start learning how to solve the non-homogeneous differential equation, let me introduce a new notations for differentiation. A new notations for the differentiation. I think all of you know that y prime, it is dy over dx. Am I right with this notation? The y dash, it is dy over dx. Am I right?
Yeah.
Yes. Now, a new notation, instead of writing y prime, I'm going to write dy. So starting from now, dy, that means the first derivative. So if I ask you, what is the d of sine x? D of sine x? Cosine x, the first derivative. And by the way, d squared of sine x, it is the second derivative, so sine x double primes. So this is a new notation, okay, for differentiation. And I can call d this capital D differential operator. Differential operator, that means you need to find the derivative. Here, the double prime as d squared, third prime as d cubed, okay? Now, in general case, if I have linear differential equation which is non-homogeneous, notice here you have some terms here, I'm sorry, here you have some terms. So here you have a1 of x, y prime, and also you have a2 x of y double prime, and so on. I think you understand this equation. So here the nth derivative and n minus 1. Now let me write this equation in the new notation of the differentiation. So instead of the prime, you will write d. Instead of double prime, you will write d squared of y. So my equation, it will be similar to the following. Look to my equation. Instead of the nth derivative, I have dny. Instead of the nth minus 1 derivative, I have n minus y times d, or not times d. This one, it isn't a product. This one, that means you need to define the differentiation of the yn minus 1 times. Now, what about of this? How can I write? I can write it a2x d squared y, second derivative of y. Also, this one can be written a1x dy, and so on. Okay? Now, I can write this expression. And by the way, look to this expression. Here you have nth derivative. Here you have nth minus 1. Here you have second derivative. Here you have first derivative. I can write this differential operator or derivative operator as the following. Look what I did here. Some students can say that I take the y common factor. Actually, isn't right to say I'm going to take y as a common factor, because here no product between d squared and y. No product between d squared and y. D squared y, that mean find the second derivative of y. And dy, that mean find the first derivative. It isn't a product. And dny, it isn't a product between d to the n times y. It is find the nth derivative of y. I can write my operator in this formula. Okay? So now this expression mean find the nth derivative of y, nth minus 1 is derivative of y, okay, and so on. Now let us take also a new notation. Instead of all this expression here, instead of all those, I'm going to use L. So we agreed now that D is the first derivative. L is this linear expression. So something times the derivative of order n, something times the derivative of n minus 1, and so on. Okay? L, and don't forget this y, Ly. So what I mean by Ly, it is some derivatives of the y multiplied by some functions. I will repeat. What I mean by Ly, it is some derivative times function, some derivatives times function of the function y. Okay? And notice also, let me write here, look what I add here. I need to add the following, that this, so this is Ly. So what I mean by L, as we agreed, it's all those. Some derivatives of the function y multiplied by some specific functions. So, doctor, we agreed about Ly. We understand what do you mean by Ly. But what about of PT? What is this PD? Let me explain it here. So the P from the word polynomial. So if I have the following polynomial Px, and by the way, you have polynomial of first order, second order, third order, fourth order, and so on. Let me write my polynomial as the following: 3x squared, 3x cubed, let me say, minus 7x squared, plus 11x minus 1. Okay? Now, if I ask you to give me b of 2, how to find b of 2? Help me, please.
substitute 2
Yes.
in place of x.
So it will be 3 2 squared minus 7 2 it's cubed minus 7 2 squared plus 11 2 minus 1. You will find your answer. Now, if I ask you to give me P of apple, help me please. P of apple,
Will be 3 apple cubed
3 apple cubed minus 7 apple squared plus 11 apple minus 1. Give me P of D. P of D. Give me P of D, please.
3d power 3.
3D cubed minus 3D squared plus 11D minus 1. So the PD, which I wrote it here, it is the polynomial. It is that same polynomial, but replacing the x by d. Replacing the x by d. Don't care about the bd. I only need ly and the notation d. We call d and l, those two are called differential operators. Okay? Look, now what I need you to solve. So I have this differential equation. It's homogeneous, yes, you are right. But the coefficients aren't constant now. So you can't solve this differential equation depending on the rule which we studied in the previous lecture. Now I need you to use D operator to express this differential equation and the L operator. Also, I need you to check the form of the left-hand side when your y is similar to this form. Let me do that here in this slide. So here the solution. Let me do first one. He need me to express this differential equation in terms of D. Can anyone help? Instead of y double prime, what should I write?
D power 2 of y.
D power 2y. Great. Plus, continue please.
2x dy
dy, great, plus 5 minus x squared y equals 0. So this is the expression of my differential equation in terms of D operator. Now, if I need to write in terms of L operator, I can write the following: D squared plus 2xd plus 5 minus x squared, all between bracket y equals 0. Now, when students will ask, Professor, did you take the y as a common factor? Actually, I didn't take, but you can do it as take y as a common factor. Now, all those are my L. So here I have L of y equals 0. Let me write the bracket like this. It's better. L of y is equal to 0. Okay? Any question about the first question? We wrote the D and L operator. So all those are L. All those are L. Second question. What will be the left-hand side if y equal e to the mx? So my y, it is e to the mx. My y prime, because my differential equation has y prime, it is m e to the mx, if I'm right. And y w prime, if you remember, it is m squared e to the mx. Let me plug in my differential equation. That will give me m squared e to the mx plus 2x m e to the mx plus 5 minus x squared e to the mx. And I think all of you remember, to simplify this, let us divide by e to the mx. So I have m squared plus 2xm plus 5 minus x squared equals 0. What do you think about the last equation which I wrote here? Can you solve this equation and find the value of m? Can we do that?
We need the value of x.
Yes, so we can't, because I have two unknowns, m and x. So notice that the given differential equation can't be solved using the auxiliary technique at all because the coefficients aren't constant. So, Professor, if I have a differential equation like this, the coefficients aren't constant, how can I solve it? Actually, today and tomorrow we can't solve it. After tomorrow, we will learn a method which will help me to solve differential equation with non-constant coefficients. Okay? Linearity probability. Yes, this idea is very easy, by the way. I'm going to understand. So do you remember if I asked you to find the derivative of the function, let me call the function, first of all, it's easy. Sine x plus e to the x. I need you to find the derivative of this summation. How to find the derivative of the summation? Any help? Could you please help? How to find this derivative of the function?
We find the derivative for each function and we
Yes.
add them together.
Yes, you are right. I'm going to find the derivative of the first and the derivative of the second. I'm going to add them together. You are right. Actually, we call this probability linearity probability of the differentiation. And the general formula for this, if I have a number a multiplied by a function f plus number b multiplied by a function g, and I need to find the derivative of this summation, the rule of linearity probability say or state that a times f prime plus b times g prime. So don't care about the numbers and find the derivative of each one of the functions and add them together. We call this probability linearity probability. The same for D. Because the D, it is the prime. The D, it is the prime. Am I right? So I can apply the same rule. And also L has the same probability. If you have L and summation, you can take the numbers out and L for each one alone and the plus between them. Because also L, it is some derivatives. So the linearity probability, you can find the differentiation of each one alone. Okay? Now, the superposition. Any question?
Doctor, I don't understand the difference between the L and D.
The difference between L and D, yes. I'm going back here to the problem which we solved. Notice here, instead of y double prime, I wrote what? D squared. So the D, it is the first derivative. The D squared, it is the second derivative, finished, of D. Let us move to L. The L, notice the L. It is D squared and D, and you multiply the D by a coefficient, and you have something here. So the L can be considered as a linear combination between some derivatives. So the L contain more than one derivative, D squared, D cubed, and you multiply the D by a number and D squared by a function and add something to them. Is it clear now?
Yes, Doctor, بس يعني how does that help us solve the problem?
Wait me, I didn't start solving the problems. Only now I'm going to introduce those notations. But till now, we didn't start solving differential equation, okay? And by the way, I'm not going to use them to solve the differential equation in this lecture. I need those notations, and they will help me to solve the differential equation in the coming lecture, not today lecture. Okay?
Good.
Yeah. So one student can say the L is a general than D. So now the superposition principle. This theorem is very important and the proof is very easy. It's stated in your textbook. No need to read it. Isn't important for me. But the idea of this lecture is as the following. If you have first differential, so this one, no, Professor, what do you mean by equation number one? Equation number one is what? This is equation of what? Is it differential equation or no? Don't forget that Ly, yeah, Ly, it is some derivatives of my function y. So maybe, look, it is y3 primes plus x squared y double prime minus x cubed y prime plus 7y equal my g1x now as an example to let you understand it is sine x. So this is the first differential equation. Now this is the second one, and I'm going to write a simple example. But is there anything common between equation 1 and 2? I notice here g1 and g2, those two different functions. What do you think about this ly and ly? The same. That means your second differential equation must have the same left-hand side. So my second equation, so let me call this equation number 1. And second equation, the same left-hand side, y3 primes plus x squared y double prime minus x cubed y prime plus 7y. Now your gx, you are free to choose your gx. I'm going to choose it to be e to the x. A simple example. This is equation number 2. I'm trying to explain the theorem. So I have two linear differential equations, number 1 and 2. Now my y1 is solution for equation 1. So let me write using the red. Here I have y1 solution. And I have for equation number 2, y2. So you have two differential equations with the same left-hand side, but different right-hand side. And you have two solutions. For each one, you have one solution. Okay? And now you need to find the solution of the following differential equation. So here, the idea that I have first differential equation, second differential equation, solution of the first, solution of the second. Okay? Now, if I need to find the solution of this, a new equation, isn't the first one and isn't the second one. But is there any relation between the third equation here and 1 and 2? Is there any relation or anything common between them? The same left-hand side. But the right-hand side, focus about the right-hand side. It is similar to the first one and similar to the second one. It's a linear combination between the both right-hand side. So the rule said the solution of the new differential equation is given by y equal the first one times the first constant, and the second solution for the second differential equation times the second constant. No, professor, we didn't understand. Let me explain in my example. So I have this differential equation number 1 with solution y1, and I have differential equation number 2 with solution y2. Professor, what about of y1 and y2? Don't care about them. In your example, you will find a specific y1 and y2. Now I don't know them. Now, if I asked you solve the following differential equation, which is the following: y3 primes plus x squared y double prime minus x cubed y prime plus 7y. So the same left-hand side, notice, the same left-hand side now, the same left-hand side, the same left-hand side. So, but my right-hand side, it is 3 sine x plus 7 e to the x. Look to your right-hand side, it is the first one times the 3, and the second one times 7. So you can say immediately, depending in the theorem, that the solution of the third equation here, y equal, you multiplied the first right-hand side by 3, so you will multiply the first solution by 3, plus you multiplied the second right-hand side by 7, so you will multiply the second solution by 7. This is the solution of second order, of third differential equation here. So depending in two equations, have the same left-hand side, I can find the solution of third one such that the same left-hand side and the right-hand side is the linear combination between both of the right-hand side of the given differential equations. What do you think about superposition principle? Is it clear?
Yes.
Yeah.
Clear.
So, okay, great. Let us continue now. I'm
Okay.
going to move to general superposition principle. in a simple way, I can say that in my previous example here, just 1 minute here, I take two equations. I take two equations, equation number 1 here and equation number 2. And here I multiplied by 3 by 7. What about if you have 3 equations, 4 equations, 5 equations, 6 equations, and you multiply the right-hand sides by some constant and add your right-hand side together as the same? The new solution for the new differential equation will be the same constants times the solutions of my differential equation. Okay? So here, if all those, notice, just 1 minute, yp1 is the solution of the first equation, yp2 is the solution of second equation, and ypk is the solution of the differential equation number k. Okay? Now I have a question. Is there any difference between those differential equations? Is there any difference between those differential equations? Or
no المفروض.
And what about of the right-hand side? So my first differential equation, it will be Ly equal G1. My second differential equation, it will be Ly equal G2. So G1 not exactly like G2. And third differential equation, Ly equal G3, and so on. The same Ly, yes, you are right. But my right-hand side isn't necessary to be the same. Okay? When students will ask, Professor, what do you mean by Ly? What do you mean by Ly this? Can anyone tell me what I mean by Ly? What I mean by Ly? No one remember?
Some derivatives of y.
Yes, some derivatives of y. First derivative multiplied by x squared, second derivative multiplied by x minus 1, and so on. Some derivatives of y. So your left-hand side of the differential equation, some derivatives. Okay. Now, so I have here all those differential equations, and I need to solve the following. So here, solve. So this equation, but first has a solution y1. This equation has a solution y2. This equation has a solution y3, and so on. And I ask you to solve this equation, Ly, the same left-hand side, equal C1 G1 plus C2 G2 plus C3 G3, and so on. Depending on the superposition principle, the solution of this equation y equal C1 Y1 here, C2 Y2, C3 Y3, and so on. And so on. So the general superposition principle, that means you have more than 2 differential equations with the same left-hand side. Now, in particular, in a specific case of the superposition principle. So let me give you an example here and we'll understand. So here you have y double prime plus x, y prime minus y equal sine x. Maybe sine x, don't care about the functions. And this is my second equation. The solution of this equation, it is y prime. Okay? y1, why it is y prime? I'm sorry. And you have second equation, it is the same left-hand side. Just I need to choose this to be 6, not x minus y. But now my right-hand side is 0. This is the particular case. And this equation, now I have a question. Can anyone of you solve equation number 2? Can anyone of you solve equation number 2?
Yes.
How to do that? How to solve it?
اللي هي تبقى m squared plus
Yes,
6m
right.
minus
Yes,
1.
writing the auxiliary equation, and you will solve the m squared plus 6m minus 1 in your using your calculator, and you find your m's. Okay, so you can solve number 2, but number 1 till now we can't solve it. Okay, you can guess one solution of differential equation number one. So using inspection, by inspection, you can find solution for equation number one, or by guessing. But equation number two, you can find exactly the solution for this differential equation. Let me call the equation, the solution for equation number two, y2. Okay? And let us agree, instead of writing y2, I'm going to use yc. Okay? So what I mean by yc, it is the solution of the homogeneous equation. And instead of y1, I'm going to write yb. It is the solution of equation number one, which is non-homogeneous because the right-hand side isn't zero. And I'm going to find only particular solution by guessing. By guessing, okay? So I understand now those two equations. Now, if I need to find the general solution of equation one, because notice now, I'm going to write the following equation, and I need you to find its solution. So solve my question, solve the following equation. Y double prime plus 6y prime minus y equal 1 times sine x plus 1 times 0. Can anyone of you give me the solution of this equation? It is very
YB
easy.
plus YC.
Great. Y equal YP plus YC. YP plus YC. Look, David said it is YB, which I'm going to find it from here. Maybe to make it more clear for the students, I'm going to write 1 times YB and 1 times YC. 1 times YC. Because here I multiplied by 1, so I'm going to multiply here by 1. And here I multiplied by 1, so I'm going to multiply here by 1. Because the sine x is this, and the 0 is this. And the superposition principle said, if you have a new differential equation with the same left-hand side, but your right-hand side is a linear combination between two right-hand sides, so only to find the solution, do the same constants here. Do the same constants. So this for the homogeneous equation. What I need you to understand from this slide, that if you have non-homogeneous equation, you can easily guess one solution for this by guessing and solve the associated homogeneous. So what is the difference between those two equations? The difference that I choose my gx to be 0, but the same left-hand side. I call this equation associated to this. And you can solve this one easily. How to solve this one? You can solve this one using the M rule, because it's homogeneous, okay? Now, to solve this, only you need to find particular for it and to find the solution of this, then add them together, okay? Also, let us check number 2 here. Now, I have y1 and y2 are solutions for equation number 1. Okay? So here, this has two different solutions, y1 and y2. Let me write here. My first equation, so to make it easier for the students, my first equation, it is Ly equal gx. And with the solution y1. Okay? And my second equation also, it is L of y equal g. Professor, the same Ly? Yes, the same left-hand side. Professor, the same right-hand side g? Yes, in my special case, the same g. And here I have second particular solution. So this equation non-homogeneous. David guess one solution, and Rahma guess the second one, y1 and y2. So I have two different solutions. Now, the idea. If I asked you to give me the solution of number 2, where is the number 2? It's homogeneous. So solve this equation, L of y equal 0 times just 0 time, no, not 0, 1 times g minus 1 times g, which is 0. Okay? Can anyone help to find the solution of this? Can anyone guess? The same left-hand side. And your right-hand side of the third differential equation is the linear combination of the two right-hand sides here. So the solution of the new one will be the same constants. So 1 times y1 minus 1 times y2. So here I have here Ly equals 0 homogeneous. So what I need you to understand from number 2 here, that if you have equation number 1 which is non-homogeneous, and you have two solutions for it, so you can solve equation number 2, or you can find solution of equation number 2 which is homogeneous by subtracting between the solutions of the non-homogeneous. This idea isn't important. The most important thing is here. Let me explain more in the coming slides. Don't care, I'm going to explain more. This a motivating example. Look, let me do everything in details. Find the general solution starting from today's lecture. The general solution for the homogeneous equation with the right-hand side is 0. I'm going to call it YC, complementary solution. Okay? Let us agree together. The solution of the homogeneous equation, it is YC, and I'm going to call it complementary solution. Now I need to solve this. Can anyone help? How to solve this equation? It's very easy, by the way.
m power
Discuss
4 minus 1
Yes.
equals 0.
And by the way, we did in the previous lecture. Let me write in the black slide now. So my differential equation, y fourth derivative minus y equals 0. The solution. So here, the solution. I'm going to write the m to the power 4 minus what? Minus 1 or minus
1.
m?
One, yeah,
Minus
doctor.
1 equals 0. Okay. No m here. Can I take m common factor? No, I can't, because the number 1, no m. So I can factorize. If you remember, we did the same equation in the previous lecture. It will be m minus 1, m plus 1, m squared plus 1, if you remember. Now I have the first m is 1, and the second m is negative 1, and the third and fourth m is what? I forget this.
X, yeah, doctor.
X, no. From where you
I.
find this x? I or
Negative 1.
positive and negative I. You are right. That will give me y equal, focus please, and I'm going to call it yc because my equation is homogeneous. Focus. C1 first constant times, if your m is 1, so the solution is what? I forget, and I don't have my cheat sheet. Can anyone help? If your m is 1, so the solution is what?
E to the x.
E to the 1x, you are right, plus C2. Now my m, it is negative 1, so I have e to the negative 1x. You have to write those rules in your cheat sheet. Please start preparing your cheat sheet for the exam from today. Now plus, what about plus I and minus I? It isn't easy. Who can help now? If my m is complex numbers, do you remember?
Yes, alpha is 0.
Alpha is 0, great. So here alpha 0 and beta
Is 1.
Beta is 1, you are right. And do you remember the rule?
Yes.
It is
It will be C3.
C3
Yes. E to the power 0.
e to the power 0x. Continue, Rahma.
Cosine x.
Cosine 1x, great. Or cosine x, you are right. Cosine x plus C4. Yes, thank you, Rahma. E to the 0x sine 4x. This is the complementary solution of my differential equation. Okay. Now let us go back and read the second question. So we've solved it here. Then find particular solution for the following linear non-homogeneous differential equation. So here the first question. Second question, you need to find particular solution of the following differential equation equal, it is -1, I guess. So you need to determine YP, particular solution. What I mean by YP, that means you need to give me a specific function with no constants such that your function will satisfy my equation in number 2. Can anyone guess? And by the way, who can guess will deserve one chocolate. And I'm sorry because I forget to give you the chocolate in exam 1. Yeah. Now, one chocolate for who can guess the particular solution for this equation. What do you think? It's very simple function.
Should we equate the right hand side to -1 يا دكتور يعني؟
Repeat, Omar. Should we?
equate السوليوشن بتاعنا اللي هو YC to -1
No.
ولا
No.
substitute فيه؟
Also, no. You need to get a function such that maybe the function it is the YC. I don't need to say anything now. But the idea here, you need to guess or to give me any function such that if I plug in equation number 2 here, as you see, I will get something right or a statement right. So what do you think?
ما احنا we said لما تبقى left hand side زي left hand side
Yes, I need my left hand side to be like the right hand side after plugging my function. So which function do you want me to
YC
use? YC, the same. So for me, actually, before the lecture, I tried YC and substitute in equation number 2, but unfortunately, I received 0 equal -1. So unfortunately, YC can't satisfy equation number 2. Maybe it will satisfy equation number 1, which is the right-hand side is 0. So unfortunately, YC can't help. Another function. It is very simple function. You can guess a function if I substitute here.
هي
I will
هتبقى
guess.
تريج صح؟
Repeat. David?
هتبقى تريج فانكشن هي؟
Trick? No, I don't understand. What do you mean trick
قصده
function?
trigonometry function يعني
No,
حاجة
no, no, no. It's very, 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 very simple function.
M power 4 minus 1 دي
No.
هي random function يعني يا دكتور ولا؟
Yes. You have to guess it, not me.
y equal to mx دي
Y equal what?
power mx.
No. It's very simple function. And big chocolate for who can guess.
big chocolate.
Yeah, but you need it. So
دكتور
yeah. Is David?
e power x plus 1
No. E to. So you need me to choose my y. Repeat, David. My y to be what? My y be to be what?
e power x plus 1
Plus 1 up here or plus 1 here?
لا تحت.
Let me check. But I'm sure is wrong. The fourth derivative of this, it is e to the x. Am I right? A plug in here, e to the x minus. I'm not sure you are right. I'm not sure. Yes. So it will be here. The y, it is also e to the x minus plus 1. I think you are right. Minus 1. Great, David. So e to the x minus e to the x minus 1 equal -1. I'm going to cancel out this with this. So -1 equal -1. So big chocolate for David. David, I think yesterday you received, you deserved and before exam one. And if, actually no, after the lecture, I'm going to speak about this idea. So now, yes, you can choose this function to be a solution for this differential equation, because I find here the fourth derivative and plug in here and I get something right. You are right. This is YB, the first YB. Can anyone guess simpler YB and also one chocolate? If no one can do that, so I'm going to say, and I will eat this big one. I can choose my YB. I can choose my YB to be only one. Let me check. Let me check if my YB now satisfy if this equation or no. So the fourth derivative, it is 0. Let me plug in here. 0 minus my Y, it's 1 equal -1. So -1 equal -1. So big chocolate for me. Okay, is it clear? So the guessing, you need to be good in differentiation to guess solution. And by the way, in the coming lecture, we are going to study a specific technique to find YP. So don't worry if you aren't good in guessing solutions. Okay? So,
Doctor,
yes, David.
YC, why is it sign for X?
Repeat, David. YC what?
Why is it sign for X? The last term.
It is here you're asking me about this one. It is 1x. Yes, David. It is 1x. But I think yes, it is 1x because I have here the beta is 1. Okay, 1x. So and this is YP. We solved it. Any question about YP? Don't ask me, Professor, how to guess in the exam, because I'm not going to ask you to guess. I will teach you a specific method to find YP. Now, let us read the third question. Then the general solution for the non-homogeneous, notice now, so third one. So this is YB particular solution for the non-homogeneous. To find general solution for the non-homogeneous, we are going to add y equal, we are going to add YB plus YC. As we did in the theorem, look, let me go back here. The theorem said only you need to add YB plus YC to find the general solution for the non-homogeneous equation. So it is 1 plus C1 e to the x plus C2 e to the negative x plus C3 cosine x plus C4 sine x. I wrote the e to the 0 is 1. Any question here? So now, also in this slide, I summarized the rule that if you have non-homogeneous equation, if you have non-homogeneous differential equation like this, okay, and homogeneous equation, and you need to find general solution for non-homogeneous one, the solution is given by this formula, which is YB plus YC. What I mean by YB, particular solution maybe by guessing for the non-homogeneous. And what I mean by YC is the complementary solution for the homogeneous. You can find it maybe using the auxiliary technique. I call YB particular for equation number 1, which is non-homogeneous. And I'm going to call YC complementary for the associate homogeneous equation. Okay, so I need this slide. I'm going to depend on it to solve the coming problems. Here also I summarize again, so no need to read it again. Or here, actually I here write the steps. So if I asked you to solve this equation, if I need you to solve this equation, notice this equation, it's non-homogeneous. What should I do to solve it? First step is to solve the homogeneous. the associated homogeneous by taking the gx to be 0. How to solve the associated homogeneous? Can anyone say how to solve the homogeneous equation?
The auxiliary
The
equation.
auxiliary. By the way, after 2 lectures or 3 lectures, you can't use the auxiliary to solve some of complicated differential equations, and we are going to learn another technique. Second step, after finding the solution of the homogeneous, and I'm going to call it YC, I'm going to find particular solution of the non-homogeneous. How? By inspection, by guessing, by cheating from your colleague. You are free, but I need YP. Okay? In the coming lecture, we are going to learn a specific method to find this YP for also some kind of the differential equations. Then third step is to find the general solution of the non-homogeneous by adding YB into YC. Okay? This is step by this slide is the most important slide in today's lecture. Yeah. Now, just 1 minute. Actually, the lecture is finished, but we are going to do the worksheet together. But before that, let me introduce what I'm going to explain in the coming lecture. In the coming lecture, we are going to learn, as I promised you, that we need a specific method to determine that YB for the non-homogeneous differential equation. Actually, I have more than one technique to determine YB for the non-homogeneous differential equation. The first one, we call it undetermined coefficients method. Undetermined coefficients method to find YB. This method can be used only if the right-hand side, this G, is one of the following functions. Maybe constant. I'm sorry, this constant, not for this. Maybe constant, so my Gx constant, or polynomial, or exponential function, sine, or cosine function. But if this Gx may be tan, no, I can't use this method. Undetermined coefficients can be used if the right hand side ln x, no, I can't use it. If the right hand side sec, I can't use it. I can't use this method. So which method should I use? We are going to learn. But now, if my right hand side Gx, maybe polynomial. Do you know what I mean by polynomial? Can anyone of you give me an example of a polynomial?
Something like x squared plus x plus 1.
Yes, you are right. Plus 11. It's something of x with power, with integer power. You can't say it is x to the -2. You can't. This one isn't polynomial, and I can't use this method which we are going to learn in the coming lecture. We can't at that time. If your right hand side e to the x, yes, I can. If your right hand side sine x, yes, I can. If your right hand side e to the x sine x, yes, I can. If your right hand side x squared e to the x times sine x, yes, I can. So the most important thing, polynomial, exponential, sine, cosine, and that's enough. The product or summation, don't care about that. Okay? Now I need you to write your names, please, on chat. Write your names. And I'm going to share with you the worksheet, if no questions, such that we can do it together. Or at least I'm going to do 2 problems, and I will leave 2 for you to do by your own, or we can meet at 1 o'clock. So write your names, please, all of you. And I'm going to share with you, don't leave the meeting. I'm going to share with you the worksheet to do some problems together. Here the worksheet. Yes. Let us do together. I'm going to do number 3, but I'm going to ask not only like this question, but I need you to solve this equation. So I'm going to ask you solve this equation. Solve this equation. By the way, for the worksheet, which you need to upload to your Blackboard to be graded by your TA, you need to solve only the question here. But for me, I'm going to ask you to solve this equation. How to solve this equation? Can anyone of you remember the steps? First step is to do what?
solve the
The auxiliary equation,
homogeneous.
No, Islam said, just 1 minute, Islam. Omar said auxiliary equation. The auxiliary equation, Omar, can be used only if my equation is homogeneous. Now, unfortunately, my equation isn't homogeneous. So the first step is what, Islam?
To solve the associated homogeneous
To solve the
equation.
associated, yes. So y تبلب prime plus 3y equals 0. So you have to write your right hand side equal 0 first, Omar, then you will solve using the auxiliary. Yes, Omar. Continue now. How to write the auxiliary?
M square
M squared, okay, plus
3
3. Continue.
equals 0.
Equal 0. How to solve this one? I'm going to move number 3. So m squared equal negative 3. I'm going to find the root. So m equal, could you please help? How to find the root of negative 3?
It's gonna be I.
I. So root 3 times I, and you need positive, negative. So your m is complex. Where is your alpha? Where is your alpha?
0
0. Where is your beta?
root 3.
Root 3. So I wrote in my cheat sheet that the solution now, which I'm going to call it the complementary, it is C1 e to the 0 times cosine beta, which is root 3x, plus C2 e to the 0x times sine beta, which is root 3x. Any question about first step? No question. Second step is to find YP for the given non-homogeneous equation. Professor, we didn't learn how to find YB. Yes, but now read the question number 3 by inspection. So by inspection, you need to guess one solution. Also one chocolate for who can guess the solution, the particular solution for the given equation. What do you think? Can anyone guess?
Negative 2x.
Negative 2x, great. Who is speaking? Rahma, great, Rahma. Let us check if Rahma right or wrong. So now I'm going to find first derivative. First derivative is negative 2 and second derivative is 0. Let me plug in my equation. If I try to plug in here 0 plus 3 times my y, it is negative 2x equal negative 6x, my right hand side. 2 times negative 2 is negative 6x equal negative 6x. All right, so you deserve one chocolate, Rahma, because this is my YP. So this is first step. This is second step. Third step is to write your general solution for the given differential equation to be YB plus YC. You found YB to be negative 2x. And you found YC to be C1 cosine root 3x plus C2 sine root 3x. Notice your solution here has two constants. I think it's here plus. I'm so sorry. Has two constants, C1 and C2, because my differential equation of second order. By the way, only this steps here. Let me use the blue. Those steps for the question in your cheat sheet. But those here, number 1 and number 3, those because I asked you to solve the equation. But in the worksheet, no need to solve the equation. Any question? Professor, I have a question. Yes, go ahead. I'm not sure if I can guess the solution in my exam. No, in your exam, no need to guess, because I'm going to teach you a specific method to find it. By the way, if you can guess in the exam and you will write by inspection, my particular solution is this, and you are sure that this one is right, so you will take full mark. No problem for me. Okay? But actually, I'm going to study differential equations such that guessing the particular solution is very difficult. So you need to learn our coming methods. Another question? So do you have any question? Let me do another problem now from the worksheet. I'm going to do number 2. This number 2. But now I need help, okay? So express, and by the way, the worksheet must be done by the students, by yourself, not me. Each one of you must do it. So please try to practice or try to share with me now. So express the differential equation, this one, using the D operator. Who can help to write the D operator for this differential equation? Yes, Islam.
The d power 3y.
D power 3y, just 1 minute. D power 3y, continue.
Plus 2 d square y
Plus 2d squared y, great, minus
minus 13 dy
dy, okay,
plus 10y.
plus 10y, great, equal sine x. This is the D form of my differential equation. Also, he need me to factorize L if possible. Where is my L? Where is my L?
اللي هي الديز يعني ناخد الواي كومن
Yes, yeah, okay. By the way, I said in my lecture, take the y common factor, but also I told you, isn't right to take y common factor because no product here, it's a derivatives. But we can together say take y common factor. So I'm going to write here d cubed plus 2d squared minus 13d plus 10 of y equals sine x. My L is this one. This is my differential operator. Okay, so my L, let me write here my L, it is d cubed plus 2d squared minus 13d plus 10. Yes, this is my L. He need me to factorize it. Can anyone tell me how to factorize this one? Can you factorize this? Anyone can?
Well, there was like a formula بس أنا مش فاكرها يعني للquadratic
Cubed.
أو الكيوب يعني.
Yes, there is a specific rule. And by the way, in the previous section, when students factorize it using the calculator. So in the exam, you can do what you want. So you are free, you can factorize it using the calculator. Can anyone of you do that? And I'm going to explain how to do algebraically, but using the calculator. Can you do?
D plus 5.
D plus 5.
D minus 2.
D minus 2.
D minus 1.
Great, Nadir. So you can use your calculator to factorize it. Now, if I don't have calculator, how to factorize this? I'm going to write my expression here equal to 0. And instead of D, let me use another letter. So let me use A. So it is A cubed, or X, no problem, A cubed plus 2A squared minus 13A plus 10 equals 0. So my aim is to factorize this expression without using the calculator. One of the easier methods is to guess, also guessing, one root for this equation. What I mean by one root, that you need to guess one number. If I plug in here, I will get 0 equals 0. Can anyone guess any number? And by the way, I need to use B instead of A, because some students will read the A as 0. It's a B. Any number, don't or any letter. Can anyone guess a value of B such that if I plug in here, I will get 0 equals 0?
1 يا دكتور.
1, you are right. Let us check. So here you have 1 plus 2, because 1 squared, so I have 3, minus 13, so it's negative 10, plus 10 is 0. You are right, great. So after finding or guessing this one, I'm going to divide long division, which all the students love it. You take your expression, b cubed plus 2b squared minus 13p plus 10, divide by p minus your number, minus 1. Do you remember the long division? Now, how to do that long division? I'm going to divide b cubed divided by b. b cubed divided b, it's b squared. So b squared times b, it's b cubed. b squared times negative 1, it's negative b squared. I'm going to subtract. b cubed minus b cubed, 0. 2b squared minus minus, it's a plus. b squared, it is 3b squared minus 13b plus 10. Now, 3b squared divided b, it is only 3b. Now multiply 3b times b, it is 3b squared. 3b times negative 1, it is negative 3b. Subtract. Now 3b squared minus 3b squared, 0. Negative 13b minus minus, minus minus, it's a plus. So you have negative 10b plus 10. Now negative 10b divided b, it's negative 10. Now negative 10 times this term, it will be negative 10b. Negative 10 times negative 1, it's a plus 10. Subtract, it is 0 here, 0 plus 0. So I can write, instead of this expression, the product between my answer and this term. So this is p minus 1 times p squared plus 3p minus 10. Now I have a quadratic expression. I can factorize it easily. So b minus 1 as it is, and here 2 brackets. Now the product is, so here you have p and here you have p. The product of my two numbers is 10. So I have 5 and 2. Here the subtraction is plus 3. So the greatest one is positive. So plus 5 minus 2. Let me check if my solution similar to another solution here. So I have p minus 1, it is here. I have p plus 5, it is here. I have p minus 2, it is here. So the same. So you can factorize the cubed expression by guessing first solution or first root, then divide long division. You will get a quadratic expression. You can factorize it easily, or you can use your calculator. You are free. Is it clear? Any question? And by the way, for those students who need or who decide to use the calculator to factorize this in the exam, they must practice now how to use the calculator to factorize it. Not in the exam, because in the exam I noticed some students write in the calculator and delete, write and delete, because they didn't practice at home. Okay? So any question now? If no questions, don't
Doctor, can you repeat that again?
Repeat what, Muhammad? You want me to repeat what, Muhammad?
You said something about the exam.
Yeah, so in the exam, so if you decide, Muhammad, to factorize this, if you decide, just 1 minute, if you need to factorize this expression using the calculator, as Nader said, so factorizing this in using the calculator in 1 minute, okay? So you need, so now after the lecture, you decide, I'm not going to practice how to do the long division because I'm going to use my calculator to do this in the exam. My idea, you have to do it today or before the exam to do the factorizing using the calculator. So you need to practice how to use the calculator before the exam, because some students, I noticed during the exam, they can't use the calculator. So also, if you decide I'm going to use a calculator, you have to practice before the exam. This is my idea, Muhammad. You have another question? Yes. So if no questions now, don't forget that you need to write your solution for this worksheet and upload to Blackboard to get the mark of this worksheet. I have a question number 1 and a question number 4. You need to do them. And if you have any question, we can meet at 1 o'clock. Okay, so please start solving number 1 and number 4 and write all your solutions for 2 and 3 also and submit your worksheet. And if no questions, we can meet at 1 o'clock if you need to discuss with me number 1 and 4.
Well, Doctor, can we be asked to factorize an equation with a power greater than 3 يعني ولا?
In the exam?
Yes.
Actually, I'm not going to ask you factorize it. I'm going to use this factorizing to solve differential equation, okay? But actually, if you have more than 3, so it will be 4, yes, of order 4. And usually order 4 is similar to what we did in the previous lecture. If you remember that we choose the m squared to be n or another letter, or you need to take common factor. So don't care because number 4 is easier, or sorry, the order 4 is easier than order 3. And number 5, no need to care about it.
Okay, Doctor. Okay.
Okay. Yes. Other students?
Doctor, I had a question regarding yesterday's lecture.
Yes. Do you want me to share it with you?
Oh, yes, please, Doctor.
Yes, 1 minute. So it's lecture number, we are summer. Lecture, I think, number 10, right? 1 minute.
Yes, Doctor, number 10.
Yes. This lecture number 10. Yes. Do you have a question?
It was the last question, Doctor, in the lecture.
Last question. Yeah.
يعني the one we solved اللي هو كان فيها 5x وكوساين.
This one, which I asked you to do similar to it in today's lecture. Yes. Yes, Abdurrahman, I remember you asked me to explain it yesterday.
Yes, أنا بس كنت متلخبط يا دكتور في the first part ال 5x يعني how did we know إن هي m equals 0 is repeated twice?
Yes. By the way, could you please tell me the form of the solution? Do you remember that first of all, if m1 not equal m2, so I have e to the m1 x and e to the m2 x. Am I right?
Yes.
Now, if m1 equal m2, could you please give me the solutions?
E equals to the m1x and then xe power mx.
Great, great. Now, in those, here you will multiply by c1, and here you will multiply by c2, and you will add them together. Am I right? Your c1 is a constant, maybe it's 0, and your c2 is a constant, maybe 0, 5, 10. Don't care about the constants. Okay. Now, if your m is 0, okay? If your m is 0, so your solution will be what? Tell me, please. If the m is 0.
C1 plus C2x.
C1 plus C2x. Now, my C2, comparing between this and this here. Where is your C2?
The 5.
The 5. Where is your C1?
مفيش.
0.
أو 0 يعني.
So now, Can you tell me that my m is repeated twice or no? So you have to remember the rules, then you can decide that my m is repeated twice. So repeated twice because you have here x.
تمام. طب دكتور I have a question. يعني انا الكونستنتس I put them into consideration ولا I ignore the constant اللي موجود جنب ال variable?
The 5 like this and the 4 like this. Ignore them. Don't care about them because those are random constants. Don't care about them. And by the way, here I choose the c to be 0. Okay? So if I add here number 1, so let me clean those. So if I add here 1 plus 5, 1 plus 5. So the same solution because your C1 is 1 and your C2 is 5. So don't care about the constants, the numbers.
يعني حتى دكتور لو زي ما عملنا مثلا ان الام ب 0 وعندي 1 فمش فارقه طالما في constant
Because because if I have here 1 or if I have 3 plus, now where is your m here? Where is the m? So
it's still 0 يعني?
It's still 0 because here you wrote the solutions. You wrote the solutions C1 plus C2x. Am I right? So your C1 here, it's a 3. This C1 comes from where? It is C1 e to the mx. And now my m is 0. So the constant alone, that means my m is 0. Is it clear?
Yes, doctor. Thank you, doctor.
Great.
Doctor.
Yes.
Oh, the one in the next slide, slide 18, and I didn't understand it.
Yes. The last, yeah, this one.
Yes.
Yeah. Actually, this one isn't included, so we don't care about it.
Okay.
Other students? So if no questions, please try to start solving the worksheet because I need you to practice. And if you have any question, we can meet at 1 o'clock, okay?
Doctor.
Yes. Okay.
Doctor.
Yeah. Yes, Mahmoud.
هو in today's lecture I always have to find the YC, right?
Yes.
Okay, even if my g of x is the same.
Even if my gx is what?
Is the same. يعني in both equations my g of x is the same, they're not different.
Yes, you need to find the YC always.
Okay, thank you, doctor.
Welcome. Other student? Welcome, Abdulrahman. Other students, do you have any question? So
Yes, doctor, I wanted to ask about lecture 9, something in linear independence.
Yes, I'm going to share number 9. This number 9. It's here. Yes, Rahman. Which slide?
13.
Yes, Rahman.
Yes. Here in the method, we determine that C1 equals 0 and C2 equals 0 and C3 equals 0. When can I find that C1 and C2 and C3 are not equal 0?
Let me do maybe example number 1. Okay, so I'm going to use the pen here. Number 1 or number 2. So your question now, can I find the C's here not equal 0 and say dependent functions? Look what I'm going to do. So I'm going to write my functions. So you need to write C1 times the first function plus C2 times the second function plus C3 times the third function. Okay, and I'm going to write my answer 0. Now, if you can't find those C's such that one of them isn't 0, you will say that those functions independent. But if you can find one of them at least not 0 and your equation satisfied, so those functions are dependent. Now, for me, I'm going to guess my C1 is -1 and my C2 is 1 and my 3 is 1. So I suggest those C's and let me check if my equation satisfies or not. Okay. Now the C1 is -1 times 1, so I have -1, plus C2 is 1, so it's sine squared, plus C3 it's also 1, so it's cosine squared, x equals 0. I'm not sure if it's equal 0 or no. Sine squared plus cosine squared, it's 1, so plus -1 equals 0, 0 equals 0, satisfy. So I found specific C's not equal 0, so the equation, the functions are dependent. Now, for this problem, Salma, Rahma, sorry, can you find the C's, C1 and C2 and C3, such that at least one of them not a 0, and your equation is satisfied? If you can, so you will say that those are dependent, but actually you can't. So you have time if you need to guess some C's such that one of them not 0. I'm not sure if this is your question, Rahma. Did you get the idea, Rahma?
Yes, I got it, but يعني in the exam, should I guess or should I solve it with the determinant, which is better?
You are free. So you have two different methods, by guessing maybe the C's or by finding the Roniskin determinant. And you are right. I don't need to guess. Let me use the Roniskin determinant. Sometimes I will give you complicated functions and the derivatives are very big. So at that time, maybe it's better to use the C's. You will decide. Don't worry, you are free.
Okay, thank you, Doctor.
Welcome. Other students?
دكتور هو بس I solved the other two questions في worksheet يعني I need to make sure in final answers بس.
Yeah, so you don't want to join again. Am I right?
لا هو لو حضرتك تعمله at one أنا عنديش.
Yes, let me check. So here, so how did you factorize the L? You take the first one.
That will be 25d squared minus 4.
So you take the D common factor. Am I right? So here no D. So how did you factorize this?
d minus 2 over 5 times d plus 2 over 5.
No, you are wrong. Because your L, it is 25 d squared minus 4. You can't take the or divide by 25. So to factorize this, it will be 5d minus 2 and 5d plus. Okay, you can't divide by 25. Okay, David?
And why?
Because to divide by 25, you need two sides. Or did you divide from the beginning here? Did you divide your equation by 25 from the beginning? Or only after writing this L, you divide by 5? Did you divide from the beginning?
No, I didn't.
So here, if you wrote here L equals 25 d squared minus 4. So how to divide it? If you need to divide by a number, you need an equation. Or you can take 25 common factor. You can take, so it will be d squared minus 4 over 25. Yes, I can write this. I can. But if you say this equal, so this equal d squared minus 4 divided 25, no, this is wrong. Because if I need to divide, I must divide both sides. Okay?
Okay.
Could you please give me 5 minutes? Then I will join again, David. And I'm going to solve number 4 before then number 1. Okay?
Okay.
So I'm going to end the meeting now and I will join again.
Okay.
Okay? Yes. Number 1, do you have a question? I'm going back, okay? So bye-bye, everyone.
Bye.
Bye-bye.